Today's topic is reflections in the axes. You can use the date of May 19th, and you're going to want to find either a ruler or some kind of straight edge before we go on with the notes. The note packet has 5 pages. These are the first 3, and hopefully this packet is pretty well put together. And these are the other 2 pages that you need. We're going to start with some basic vocabulary before we actually get into the reflections. Whenever you perform any kind of transformation, and there's 4 different types, typically we do a lot of graphing in the coordinate plane. So either they'll pre-print the image for you, or they'll ask you to graph it. So when you start the graphing process based on the points that they provide, that original figure is called the pre-image. When you transform the figure, it will become the image of the pre-image. And the reason we know that it's the image is we mark it with what's called prime notation. So the blue figure is my pre-image, the red figure is my image. And you can see right here, this is P with a tick mark. We read that as P prime. This is Q prime and R prime. And because it has that tick mark, I know that that is the copy. It's really important that you label all the points that you graph. So we want to be able to identify the pre-image and the image through your graphing process. Sometimes, even though the figure is undergoing a transformation and it should either move to a new location or flip over, some points do not move. We call those invariant points or fixed points. They actually will undergo the transformation, but however that transformation is set up, it leaves the pre-image and the image in its original location. This is our official definition of a transformation. Basically, we're in the coordinate plane and graphing, and each point there's going to be a one-to-one correspondence. So what's going to happen is we'll take the pre-image and we'll be able to locate the image under that transformation. So every point has to go somewhere. All right, now we'll get into the actual reflections. So when a reflection occurs, what you're doing is creating a mirror image. Now this could be on strictly a point, it could be a line segment or a line, or it could be a figure. We're going to stick with figures because it's much easier to see and understand the process. When you reflect, you can think of it as a flip over a line. So we're using the line of symmetry that we talked about yesterday. In this first image, the tree, you can see that it's being reflected in the water or the fog. We would have a horizontal line of symmetry right here going through the center. For the 2 swans, there's actually 2 lines of symmetry or 2 lines of reflection. One is the water, so it's horizontal, and we can see the swans reflected in the water. And they're pretty close in size and shape, so we could almost do a vertical line of symmetry right between them, and they would be mirror images of each other. In the last picture, the line of symmetry or the line of reflection is horizontal right here at the water line, and you can see the hot air balloons reflected in the water. So we are creating a mirror image. So for the first reflection, we're going to use the x-axis as the line of symmetry. In my image here, in my picture, you can see we have triangle ABC in quadrants 1 and 2. This is my pre-image. Down in quadrants 3 and 4 is my copy. We know that because it has A prime, B prime, and C prime. So from A, it was at -2, 1, and now it's at -2, -1. How about C? It was at +4, 2. Now it's at 4, -2. Hopefully you're seeing what's happening to the points when it's reflected in the x-axis. So we don't write out reflection. We abbreviate using a lowercase r for reflection, and then in subscript, you're going to write x-axis. So this will tell me what to do. If you're reading the information, a lot of times they will abbreviate what they want you to do. So they want you to reflect triangle ABC in the x-axis so that you produce triangle A prime, B prime, C prime. So hopefully you noticed what was happening between A and A prime and C prime. B and B prime are actually following the same rule. So the rule, and this is generically speaking, will take any random point P located in the coordinate plane with an ordered pair of x, y. It will map itself to P prime. X will stay the same and y will change. We can apply this rule for any reflection in the x-axis. But as we learn more transformations, you might not be able to remember the rule. So it's also possible for you to count. If X is my line of reflection, A going down vertically is 1 block from that line of reflection. So its new location is also 1 block further. So we drop down 1 and there it is. We can count C to the line of reflection is 2 blocks. C prime is 2 more blocks away. So we just want to identify that line of symmetry or line of reflection so that we're going into the right place. In example number 1, they're giving us 3 ordered pairs, A, B, and C, and the directions say to reflect triangle ABC in the x-axis to produce A prime, B prime, C prime. Why don't you take your straight edge right now, pause the video, you should graph A, B, and C, and then make your triangle. If it's graphed correctly, you should see it mostly, well, actually completely contained in quadrant 4. You want to make sure you label all the vertices with A, B, and C. Whenever we do a transformation, we complete what's called a full mapping. We always list the 3 original points vertically, and then we go ahead and apply the rule. So we put the rule above the mapping arrow, and then you tell me where A prime is located. The rule says X stays the same, Y changes to its opposite. Let's do that with B. X stays the same, Y becomes its opposite. And C prime, X stays the same, Y becomes its opposite. When you do this for homework, I want to see this full mapping, original points, rule with arrows, and the new points. Now that I know the location of A prime, B prime, C prime, I'm going to go ahead and graph that. You can pause the video if you want to graph it first. And there it is, A prime, B prime, C prime. So if I were to fold my coordinate grid on the x-axis, these 2 triangles would overlap each other perfectly. Let's try example number 2. Take a minute and plot A, B, and C, and use your straight edge to connect the points, and then we're going to, again, reflect it in the x-axis. What I've done in this example is I've changed the location of B. I did make it go up 2 units. So now that it's graphed and labeled, we're going to apply the rule, reflect in the x-axis, X stays the same, Y becomes its opposite. We'll do the same for B prime. X is the same, Y is the opposite, and C prime. And now that I know their location, we can go ahead and graph A prime, B prime, C prime, and label it. The reason I like this example so much is in the first example, the first triangle was completely contained in quadrant 4. But in this example, my original triangle was lying across the line of reflection. When that happens, the image will also lie across the line of reflection, but they will overlap each other. So this is actually quite normal, but you can kind of predict what's going to happen. In this lesson, we're also going to reflect in the y-axis. That's our vertical line. So again, A was at 2, 2, and it went to negative 2, 2. B was at 4, 4. Now it's at negative 4, 4. So hopefully you're starting to see a pattern here. We still abbreviate with a lowercase r, but then we put in subscript that it's the y-axis. So reading it is the same. We're going to take triangle ABC and reflect it in the y-axis to create its prime image. If you notice what's happening with A and A prime, the x value now has changed, but the y stayed the same. Same thing with B and B prime and C prime. So our generic rule, you're going to take a random point P located in the coordinate plane. It will map itself under a reflection in the y-axis. X will become its opposite value, y will remain the same. Again, as we learn more rules, you might prefer to count. So A is horizontally 2 blocks from the line of reflection. Its new location is also 2 blocks further from the line of reflection. B was 4 units from the line of reflection. B prime is also 4 units. The counting method will work for both of these reflections in the X and Y axis. In example number 3, we're given 3 points, D, E, and F. If you'll take a minute and graph that with your straight edge and label your vertices. We're going to reflect triangle DEF in the y-axis. So let me graph my triangle. You'll see that it's lying across the y-axis, so I already know that the image is going to overlap my pre-image. We're going to put our full mapping down. There's my 3 original points. My rule is to reflect in the y-axis, and it maps to D prime. X changes, Y stays the same. E prime, X changes, Y stays the same. And finally, F prime. Now that we know the locations, we'll go ahead and plot D prime, E prime, and F prime. And just like we thought, they do overlap, but they do appear to be the same shape and the same size. Make sure you label with prime notation, and then your graph is complete. In example 4, they did not provide a grid. They just gave us 4 points. This is some kind of quadrilateral. They want us to reflect this in the y-axis. If you know your rules well, you don't always have to graph, and sometimes they'll tell you that the graphing part is optional. You can only skip the graph if they tell you it's optional. Otherwise, you must complete it. So the reflection in the y-axis, the rule says X changes, Y stays the same. I'm going to start with my rule and my mapping arrow, and the location of W prime, X changes, Y is the same. Oh, doesn't look like Y is the same to me. We'll make that +3. X prime, X changes, Y is the same. Y prime, and this should be Z prime. So we do know the location of our quadrilateral without a graph. So what can we conclude after doing all these examples? Anytime you perform a reflection, the figure, which is the pre-image, and its image, which is the copy, are going to be congruent. They're going to be the same shape and the same size. The only thing that might be different is that they face different directions. So reflections preserve distance between points, and that is a common property of all reflections. The homework is in the round 3 packet. It should be 2 pages. It says reflections in the axes. Make sure you do a complete mapping in these white spaces. Sometimes the graph is required and sometimes it's not. This is homework number 124. And if you have any trouble with this assignment, please make sure you get in touch with me. Remember, I'm spot checking your work, and it will go in as a weekly quiz grade at the end of the week. Have a great day.